JavaScript was never really intended to be the language for compute-intensive system-level workloads, right?
For sure.
Whereas Go was precisely intended to be that. We're going for full compatibility here. We really want this to be a plug-and-play replacement for the old compiler. But I think far more interesting is thinking about the implications of having a type checker that is 10 times faster when you couple that with all of the stuff that's happening in AI and agentic programming and whatever. And like, what could we do with information that we can produce 10 times faster, like contextual information for the LLM about like, what are these types actually resolved to? What is this symbol? Which symbol? Where was this actually declared as? Because all the LLMs look at right now is just the spelling of it. It doesn't really know. And so we could imbue it with a lot more higher fidelity information, in a real-time manner, right?
The TypeScript type checker, one of the most fundamental software development tools in the world, just got 10 times faster with today's announcement that the team has been porting the codebase to Go for months. When Anders Hejlsberg, the lead architect and co-creator of TypeScript, offered to meet with me to discuss this monumental change, I tried to think of questions library authors, power users, tooling makers, and compiler contributors might have. I'm someone who writes Rust for my day job, and I know a lot of you are wondering why didn't they choose Rust? I had that first reaction too. But in this conversation with Anders, he shared the team's vision for the path ahead, and I have to say, after hearing the technical reasoning, I'm in extreme agreement that Go is the right choice. What I hope people focus on though is not so much the choice of native language, but the fact that type checking is 10 times faster while using half the memory and being concurrent. So TypeScript is about to get quite a lot more interesting with the possibilities this new era brings, and I hope you enjoy this chance to hear about it from Anders himself. Hello everyone, we have Anders Hejlsberg here. There's a big thing happening in the TypeScript world, and he's here to talk about it and answer some questions, hopefully from a library author's perspective, from somebody who's been using TypeScript and really going to great lengths to get the most out of it. We're going to ask some questions and hear some thoughts about how all that works. So Anders, how's it going? Please tell us about yourself. Introduce yourself if you would.
It's going good. I'm Anders Hejlsberg. I'm a technical fellow at Microsoft. And also I'm currently working as the lead architect on the TypeScript open source project. And before that, I worked on C# for over a decade. And before that, I was at a company called Borland where I worked on Delphi and Turbo Pascal. So I've been doing programming languages and software development tools for about 40 years now, a little more actually. Yeah.
What a career. That's amazing. There was a time not so long ago when I was very excited in writing C# and I really appreciated everything about it. So thank you for that. But then TypeScript came along. So, maybe we can actually start at the beginning because the code name for this new project is Corsa. Is that right?
Mm-hmm.
But the word being referred to for the old code base is Strada. And I happen to have that was the original code name for TypeScript, right? Is that true?
That's correct. Yes. Back when we started, and we started, I think, in late 2010, early 2011. And that was the code name that we had for the first couple of years when we were just working on it in-house. Yeah.
Mm-hmm. Yeah, it was you and Luke, right?
And Steve, obviously Steve Luco, yes, who wrote the very first prototype compiler, which he created by grabbing the scanner and parser from our then JavaScript engine in Internet Explorer, and then repurposed it. So that was like a C code base, and just to get a proof of concept.
Right.
And Luke was our product manager at the time. Yeah. So Steve and I and Luke were sort of the initial group on TypeScript. Yes.
That's awesome. So fast forwarding to, I don't know when actually, maybe you can tell me when. So whose idea was this new direction with Corsa? Like what was the day?
Well, I'm not sure there was a one singular day. It's something that's been in the back of our minds for a long time. There's sort of been this trend in the ECMAScript community to move some of the really dependent upon tools to native code like ESBuild and SWC and what have you. There are multiple like native code parsers now and linters for JavaScript, right? And we've watched that, of course, and we've seen, and we've actually, like, we ourselves use ESBuild in building the TypeScript compiler today. And we also have, of course, watched in the community as there have been multiple efforts to attempt to build a native code version of TypeScript. Most of them by sort of starting from first principles, some by attempting to port, but none of them have sort of attained critical mass. Which is understandable because it's a complex project. I mean, we have about 100 man years invested in TypeScript, and so it's not like a single person trying to port or create something that is highly compatible. That's a huge undertaking. But we've watched all of that happen in the community, and then I think and we've had a lot of discussions about performance and scalability because that continues to be the number one ask of our users is, can we have this scale better? Can we have this go faster?
Gotta go fast. Yeah.
It does. And as it goes with all software, nothing ever gets smaller. It only gets bigger, right? And so projects are getting forever bigger. Our compiler is getting forever bigger, and that in turn puts more strain on the runtime environment that V8 and the JavaScript engine, because, that's a JIT compiled environment. And so our startup time keeps getting bigger, as we add features. And so we've sort of seen this slow upwards creep in time or slowdown, if you will. And so we had a push to do perf, and we did a bunch of stuff. But, all of it is in the order of 5 or 10%, or nothing that is like, we're not
earth-shattering.
we're just not moving that. We're not moving it all that much, right? And we've over time come to the realization that this is as much as we can optimize. And when we look at profiler runs of our compiler, there aren't really any hotspots. It just is going about as fast as it can go, and that to do the things that it does. But so, long story short, there in August, we started thinking about, well, okay, we need to get some data on what would it mean to port to native code, so that we can make some informed decisions about whether we're going to do it or not. And we started doing some prototypes. In different languages, we looked at Rust, we looked at Go, we looked at C#, we looked at, what have you. And we felt that Go was a language that fit our needs very well. And so in August, I started porting the scanner and the parser just to get a baseline so we could see, well, how fast could this go? And how hard is it to port from JavaScript to Go? And it actually progressed pretty well. And within a couple of months, we had something that we could run that would parse everything, that all the source code that we have with no errors. And we could start to extrapolate some numbers from that. And that's sort of like when we started to realize, okay, we can get to 10x with this, because we get about 3.5 times from being native, and then we get another 3.5 times from concurrency. And the two together gets us to 10x, and 10x is pretty darn dramatic. I mean, that's once you know that once you can see that glimmer, you go, okay, this is going to be hard to let go of.
Everything else kind of pales in comparison. So,
exactly. Yeah. So we kept going.
What did the rest of the team think when this? I assume there was a day when it kind of came that, wow, maybe this approach with Go and doing this has legs. What did the rest of the team think? Like, what was the vibe?
I think it was a mix of excitement and nervousness, right? Because this is totally uncharted territory. Are we actually going to be able to succeed? Are people going to be able to pick this language up and learn in a reasonable time? What do the tools look like for Go? Are they going to be as nice to work with as TypeScript itself is? Because that's where we've been hosting for like ourselves for over a decade, right? And so just a lot of oh my God, lots of unknowns, but still lots of excitement too about the potential gains.
You mentioned hosting. There's this concept for people listening of self-hosted languages, meaning they're written in themselves. So a lot of languages start in some other language. So Go started being written in C and Rust started in OCaml. But after you get some sort of critical fluff in there that you can begin to describe things in, many languages like TypeScript and Go and Rust and the rest become written in themselves. But this is like ejecting from being a self-hosted language. Is there another example of that?
Well, I think like all of the other tools that you've seen gone native in the JavaScript ecosystem obviously have abandoned because they came from
Great point.
being written in JavaScript, right?
Yep.
It is one of our biggest concerns not to be self-hosted because it has really served us well to be self-hosted. And I also believe that we're going to still have parts of this project that are written in JavaScript. It remains to be seen how much. We're still exploring, solutions for the language service. We know that the core of the language service is going to need to be in native code. The sort of the semantic engine, if you will, of where the compiler is that provides all of the information. But there's an awful lot of stuff around that could potentially remain in JavaScript. And we know that we're going to have to construct an API between, the native parts in Go and consumers that want to consume from other languages, right? So this is still something that we have not fully sorted out. But we definitely see the value of self-hosting. But on the other hand, we also are realists, And it's hard to in perpetuity leave 10x on the table. It's like on the one hand, on the other hand, which benefits the community more, right?
Yeah, absolutely. And that's a message I hope people get away from all of this. I should mention I also am a Rust developer in my day job, and I was elated when I heard of this. And part of the reason, I think the question that's obviously going to be on a lot of people's minds is why not Rust? Because a lot of tooling in the community is converging on Rust. Yes. And so I kind of wanted to ask you that directly if there was, I know you said you looked at it. I would also like to hear about why not C#.
Sure.
C# has come a long way. My understanding is since I last looked at it with the async story and something hill climbing thread pools. So maybe you could tell us a little bit about those two.
Yeah, I think one of the motivating factors here is that we are porting. We're not starting from first principles. Let's say that we were starting completely from scratch. At that point, your choice of language is something that you can shape your project around, right? And then, say if we started from scratch and we were writing in Rust, well, then we would engineer a compiler that from the beginning did not assume automatic garbage collection and did not depend heavily on cyclic graphs and what have you. I mean, but starting from first principles, you will when you have a product that has more than a decade in use, and millions of programmers, and God knows how many millions of lines of code out there, you are going to be faced with like the longest tail you could imagine of incompatibilities and whatever, because like a lot of behaviors in our compiler are, you could say arbitrary. And when I say arbitrary, I mean, in type inference, for example, there could be multiple candidates that are considered correct here, and we pick one of them. And that is, in a sense, a a behavior that programs depend upon, right? And if that doesn't fall out the same way in a new code base, then you're going to see new errors possibly, and So from the get-go, we knew that the only way this is going to be meaningful is if we port the existing code base, and the existing code base makes certain assumptions. Specifically, it assumes that there is automatic garbage collection. And that, I think, pretty much limited our choices. That starts to heavily rule out Rust, right? I mean, because in Rust, there's memory management, but it's not automatic. You can get reference counting, you can get whatever but then in addition to that, then there's the borrow checker and the rather stringent constraints that it puts on you around ownership of data structures. And in particular, it effectively outlaws cyclic data structures. And all of our data structures are heavily cyclic. We have ASTs, or abstract syntax trees, with both child and parent pointers. We have symbols with declarations that reference AST nodes, that reference back to symbols, that we have types that go around in circles because they're recursive, and trying to unravel all of that, would just make the job of moving to native insurmountably larger if we were to also have to re-engineer all of that. And so when we sort of go down the list of, we want a language that gives us excellent optimized native code on all major platforms. We want a language that allows us that has great expressiveness in data structures, allows cyclic data structures, but also allows inline data structures like structs, such that, where in JavaScript, everything you do with an object is an allocation. And we would rather avoid that, especially for little objects, if we can store them in line. And we need automatic garbage collection. And then we also knew that we need concurrency, and we need shared memory concurrency. And we can talk about the distinction there, because technically JavaScript has concurrency with web workers, but it does not have shared memory concurrency. And I can explain why we need that for the compiler, but that was also sort of a must. And when you look at all of those, and then of course we want good tooling. We all live in VS Code. We want excellent support in VS Code and whatever. And when you add all of that up, Go actually ended up coming very high on the list, right? And that's why we started prototyping in Go and found it to be a great experience. And so we kept on going.
Yeah, I mean, I think that is where the rubber meets the road. I'm extremely passionate about Rust, but that passion doesn't blind me from being able to say that Rust does not have this, learn it in a weekend sort of aspect to it. It's very focused on doing the most correct possible thing at the expense of DX whenever possible, it seems like. If you're coming from JavaScript, you're going to find the transition to Go a lot simpler than the transition to Rust. That I am convinced of. I'm glad to hear you say that, because to me, this is another really important reason, just on a human resources perspective, that makes this decision make sense, which is that if you look at some JavaScript and then you look at the same thing implemented in Go, they look pretty similar. But if you look at the same thing implemented in Rust, especially if there's anything especially complicated going on, or recursive structures, like you mentioned, it's very tough to see how the Go came from the TypeScript, from the JavaScript. I've done this before, and it's something that I think is a superpower for Go in this respect. That makes so much sense that you said all that. But tell me again, just to close the loop though, tell me about C#. Why was C# considered?
It was, but I will say that I think Go definitely is much. I'd say it's the lowest level language we can get to and still have automatic garbage collection. It's the most native first language we can get to and still have automatic GC. In C# is sort of, it's bytecode first, if you will. And there are some ahead of time compilation available, but it's not on all platforms, and it's not really, it doesn't have a decade or more of hardening, and was not engineered that way to begin with, right? And so, and then I think Go has a little more expressiveness when it comes to data structure layout and inline structs and so forth. And so for us, I will say too that, one additional thing maybe is, our JavaScript code base is written in a highly functional style. We use very few classes. In fact, the core compiler doesn't use classes at all. And that is actually a characteristic of Go as well. Go is functions and data structures, where C# is heavily OOP oriented. And we would sort of have to switch to an OOP paradigm to move to C#. And that's, again, there's just more friction in that transition than there is in the transition to Go. And so ultimately that was what was the path of least resistance for us.
Great. I mean, I have questions about that. I've struggled in the past a lot with Go and functional programming, but I'm glad to hear you say that those aren't struggles for you. That was one of my questions.
Yeah, I mean, when I say functional programming here, I mean sort of functional just in the plain sense that we're dealing with functions and data structures as opposed to objects. I'm not talking about pattern matching and higher types and monads and da. No.
Okay.
We're at a much lower level than that. Yeah.
When you look at the TypeScript code base, and for me, I haven't contributed a ton to the TypeScript code base, but I've debugged through it a lot, doing various things to try to figure out what's going on under the hood. And one of the things that has come up for me a lot in debugging the compiled output of the TypeScript code base is that the TypeScript code base makes extensive use of enums and bitwise, often unary bitwise operations on enums to track values. But Go doesn't have anything quite like that. Go has, you can kind of group consts together. It sort of looks like enums, but I'm curious if that very common aspect of the TypeScript code base has been hit at all, or what the solution is for solving that in Go world.
Sure. I think what you're really saying here is that TypeScript is TypeScript has a much richer type system than Go. And that I will readily admit. And Go does not really have concepts such as enums, although it does have concepts such as grouping consts together and
there's the Yoda thing
and the iota thing and auto numbering them. It's a little quirky and some of this stuff and the type, but there's some level of type checking of it. But it does actually have excellent support for bit fiddling and packing flags into ints, and in fact it has much better support than JavaScript for all of the various data types, right? I mean, you can have bytes and short ints and ints and 64-bit ints and what have you, both signed and unsigned, and like in JavaScript everything is a floating point number. Period.
Yep.
I mean, you want to represent true or false? Yeah, that's 8 bytes for you right there. Yeah. I mean, so that is tough. And that is why, we do all sorts of tricks in our existing compiler. At least we can pack 31 bits into a floating point number typically in JavaScript. But hey, in Go, we can use all of the bits. And by the way, we can also lay them out as structs, inline in arrays. And it shows, our memory consumption is roughly half of what of what the old compiler was. So and in these days, I mean, like, memory equals speed, right? The more memory you use, the more the slower you go, because the more times you hit the write barrier or the read barrier, and then you have to go out to the, you blow your L0 cache, and you got to go get it from real memory. It's like, I often joke, like in modern CPUs, it's like each instruction takes 0 cycles because of prediction, except when it takes 1,000 cycles because you hit the memory wall and you have to go fetch, right? And so if you can condense your data structures, you're going to go faster.
So you're making me wonder, there are some features, despite them so despite Go's type system not being quite as advanced as TypeScript is, there are some differences. Like one that I miss from, I used to write Go. One that I miss is this concept of opaque types. Like you can create an alias for a type. In TypeScript these days, people do branded types is the thing that we call it very often.
Right.
But I'm just curious if there's any. My understanding is that F# had a little influence in the early days of Strada and TypeScript. Is there any influence that you've had writing Go on a daily basis? Is there anything you've looked at and go, I wonder if we could fit that into TypeScript or anything like that?
Well, you mean going in the other direction? Interesting. Let me think about that one a little bit. But by the way, I will mention that later versions of Go actually have introduced sort of the notion of fresh types, where you can have a fresh int32 that is different from other int32s, and that's how we get type safety in or some modicum of type safety around enums, because we declare fresh types for each of them. But is there something going in the other direction? Well, I mean, it's tough because as a type system, Go is, I wouldn't say pedestrian, but it's a fairly simple type system, right? There are runtime features that I wish we had, but now we're talking about the JavaScript runtime, right? I mean, like certainly structs is something that has benefited us greatly, but whether it is necessarily beneficial for the JavaScript community at large, I'm less certain, right? I mean, the thing is, something like a compiler is actually a very, very atypical thing to run in JavaScript. It's like, I often joke, if people had told me, Anders, you'll be writing compilers in JavaScript for a decade. I'm like, what? You are nuts. If people had told me that before I started TypeScript, right? But that's effectively what I've been doing, or what our team's been doing, right? But JavaScript was never really intended to be the language for compute-intensive system-level workloads, right?
For sure.
Whereas Go was precisely intended to be that. Like, look at Kubernetes and other marquee projects that are written in Go, right? And basically the lack of any kind of UI abstractions in Go. Go is a system-level tool. And we are a systems level program. So, yeah.
It makes sense. It's a good fit. Well, I mean, let's go dig into that a little bit and talk about ensuring the smooth transition as this big change happens for the ecosystem. So right off the gate, one of the first questions I was thinking is, TypeScript doesn't have a formal specification. It's kind of like the reference implementation is the specification.
Right.
And so how are you going to be working through transitioning from that state of things to, this new code base and keeping everything kind of in line?
Yeah. Well, this in particular underscores the one of the core reasons why we're doing a port, right? Because when you're porting the code, you get the same semantics at the end of the day. You end up with a different piece of code, but the semantics are the same. And that means the same things will happen when you feed data in and expect to see a certain behavior, right?
So you don't see the AST changing in any way or something like that?
No, the AST is very faithful to. I mean, it's like we have all the same node types. It's laid out in the same manner as it was in JavaScript. But of course, the way we declared it in JavaScript, we would make in TypeScript, we make heavy use of union types and intersections and what have you, and all sorts of fancy stuff that you can't do in Go. So all the type definitions look different, but semantically, we're talking about the same thing. And that's true for symbols and the object model for types in the compiler itself. Absolutely, yeah.
That's great to hear, because I think library authors will be concerned about, am I going to have to maintain two versions of my types? And it sounds like you're going to be putting a lot of effort to make sure that there's a pretty smooth transition.
Our aim is 99.99% compatibility. I mean, we ideally want to produce exactly the same set of errors for the same code base. And that's what we've been moving towards. I mean, at this point, the compiler that we are now making available open source compiles and checks all of Visual Studio Code with 0 errors. And that's like 1.5 million lines of code. That's a big code base, almost 5,000 source files and 50 megabytes of source, I think. And so there's a substantial portion, and we're very close to enabling all of our tests. We know that we can run our 20,000 conformance tests without crashing. But we're still analyzing error baselines and whatever, and burning down some of the differences, but we're going for full compatibility here. We really want this to be a plug and play replacement for the old compiler, because that's the only way that we ever get out of the business of in perpetuity maintaining the old compiler, right? So
is there anything that jumps out at you today that you think will be the toughest challenge in making that transition? It's a good answer if the answer is no, by the way, because
no, I think it's doable. There are by necessity, there are things that complicate it.
Sure.
It's actually a long arc to get me to there, but there are certain things that we have had to change internally in the representation of our types, in particular, as it comes to ordering all of our types in a deterministic manner. And what I mean by ordering types is when you have a union of types, right? Sometimes the order matters. I mean, it matters for when you print out the union and what order do you see the types come out. But it also matters in certain scenarios for error messages when we pick candidates to report errors on, and when we do subtype reduction and other things like that. And in the old compiler, we had a sort of very simple but non-deterministic, well, it was deterministic on a single thread way of ordering the types. We would just say, whenever we instantiate or whenever we create an object that represents a type, we just give it a serial number. We just keep bumping that serial number, and fine. For you compile again, all the types get the same serial number and everything is the same over and over. But when you start running on multiple cores and you have multiple type checkers or things get checked in a slightly different order, and it's not deterministic, because that's the whole nature of concurrency, right? And so we needed to introduce a deterministic ordering of our types. But of course, that means that the ordering of our types is now different in certain cases than it was in the old compiler. And it shouldn't matter, because unions are not supposed to be ordered, but in some cases, it matters. And so we're having to work around these things, is what I'm saying. But it's doable. It's absolutely doable. I don't see, actually, I would say the largest remaining challenge is understanding how we provide a versionable and modern API to the new code base. Because for better or for worse, in our old code base, the source code was also our API specification. Hey, it's JavaScript. You can call anything from anywhere you please, right? And because you can, people do. And so all of the innards of the compiler were effectively exposed as an API. That is not going to work going forwards. If nothing else, for the reason that our code now has gone from exposing every single function in the compiler to exposing 0, because it's an exe, but that's it. And so now we need to judiciously think about, how do we put an API on that? And how do we make that API efficient in the face of having to transition between processes and talk through communication channels, as opposed to just directly pushing stuff on the stack and making a function call? Do you know what I mean? So
I know exactly what you mean. I have some projects that do what you're saying. If you call the function, it's there, but if you look at the types, it's been removed. But if you call it, it works. Yes. So
exactly, and people do.
I do. Yeah, you got me. That's funny.
Yeah.
Well, I mean, I think that it's good to hear that the JS API is something that's on your mind and you're thinking about. Can we talk a little bit about the connection points? I have to say, one of the reasons I'm very excited for this not being written in Rust is because I think it will only strengthen the connection points to other languages and open up. Like if I wanted to write an emitter in Zig, I feel like that might be easier to do if the entire API is, well, you didn't say the word WebAssembly, but I'm just curious if there's a WebAssembly component to this or how it will work to provide those. Will you have Rust bindings or will you have bindings to other languages?
I think we're going to have language neutral bindings is what for sure will be the case. And well, so one binding we will definitely have is the language server protocol, right? Okay. Because that is what we're using in the implementation of the new native language service, which, by the way, is a transition that we've been wanting to make for years. Like TypeScript, the project predates the language server protocol and was actually an inspiration for the language server protocol. But we never ourselves made the transition to LSP. That we're taking this opportunity to do that. Awesome. That will for sure be an API that is available everywhere. And you could, of course, imagine us adding additional functionality over and above the core LSP functionality that would allow you to ask different questions of the language server, right? In a language neutral manner. Now, it's never going to approach the richness of the current JavaScript API we have. And we are looking at solutions that make a richer, more synchronous API, because this is something that we ourselves would need if we were to keep building parts of the language service in JavaScript. But we have not it's just too early to say exactly how that's all going to shake out. But we're definitely doing a lot of exploration in that area right now.
Got it. How long do you expect the Strada code base will be maintained going forward, even after you consider the Go stuff to be fully generally available?
I think the probably another couple of years is what I'm thinking. But that's just because we're by nature very conservative here. We don't really want to leave anyone behind. And we understand that there are projects that need to do what they do, and we may not have an answer for them yet in the new native compiler, right? And so, but certainly by the end of this year, I expect us to have a fully functional compiler that most people will be able to use. We're pretty darn close with the command line compiler already. I think we'll get there by summer or late spring. Where people can just use that instead to do, but of course there are parts of it that are not yet there. I mean, we don't have support for JSDoc yet or JSX, although it's in flight. We don't have support for project references and build mode and watch and whatever, but that's also in flight. So it's all coming online. But we do pretty much have a compiler that will compile a single project 10 times faster than the old one, and give you the same errors if you have errors. So,
do you think that the code bases will ever be merged, or will the TypeScript Go code base be kind of like the new home?
TypeScript Go code base, longer term will be the home for our
Got it.
But then again, as I said, we are still exploring how we structure the language service, and there will certainly be a native component to the language service, but there might also be a JavaScript component to it, and of course that would be in JavaScript or TypeScript. Sorry, but yeah.
It's good to know though that it's on your mind to manage this gap. That's a aggressive timeline that you just laid out, but it also
it is, and
but it's also a long timeline for support. My buddy Anders, who has been on the channel before, and I'm sure you know him, has like 100 PRs open right now, I feel like, and that was one of my things is like, oh man, what's going to happen to Anders' PRs? But it sounds like they'll be safe and sound.
Hopefully we'll port them, right? I mean, we actually We snapped at a just some random commit, in August.
Mm-hmm.
Or I think it's probably more like in September, we picked a particular commit and said, okay, this is the commit that we're going to port. The state of the source code. So we know what our baseline is, right? And so from there on, we can then go back and then we can look at all of the PRs that we've merged since, and we can cherry pick them and whatever, and then translate them or port them.
Right.
And then so there will be that follow-on work that that's going to sort of happen in parallel, but I believe we'll get there.
That's awesome. I think that's going to be very inspiring to hear that answer to people who are tooling makers. I wanted to ask if you think that they should expect, tooling makers like linters and formatters and knip and things like that should expect their tools to also get much faster for the typed aspect of them anyway.
I think that is a hard question to answer in general. Sure. all depends on the tool and how heavily it uses the language services and how heavily it relies on semantic services from the compiler versus just AST stuff, which you could do by picking just any kind of native parser, right? And so it depends. I will say though that we are in conversation with most of the well-known tools in the ecosystem, and if we're not, then we will be. To try to assist as much as we can with getting their functionality either ported or revectored or whatever needs to happen with the particular tool.
That's very reassuring to hear that you're communicating directly with the, linter makers and formatter people. And that's going to go a long way, I think, towards making this a smooth transition for everyone.
Yeah.
So thanks for doing that.
Oh, sure. No. It's that's what we need to do, right? I mean.
So this actually is a good segue to talking about one more question about the concurrency part.
Mm-hmm.
You mentioned about the concurrency model being different also presents some challenges at the JS API. How much effort I'm just curious, has gone into the concurrency stuff? How hard was it to add concurrency? And maybe I'm wondering if you spent any time debugging, deadlocking, or concurrency issues.
Oh, yeah.
How's it been with that?
Well, it's funny because the compiler that we're porting, the TypeScript compiler that everyone's been using for the last decade, I said earlier, it's a very functional code base, meaning it has functional patterns and in particular, it makes heavy use of immutability as a tool to ensure safe sharing. For example, after we scan and parse and bind an abstract syntax tree, from there on out, we pretty much consider that syntax tree immutable. And that means that multiple type checkers can party on the same AST at the same time. Now, you may go, well, but JavaScript doesn't have concurrency, so why does that matter? Well, it kind of matters because you can have multiple projects open that have the same file in them, and this saves us from having to create multiple ASTs that are just highly duplicative, right? Plus, it also makes it easier for us to reuse data because when you think about it, like when you're sitting in the language service and you're editing in a file, you're constantly creating a new program in a sense, right? Because that file is constantly changing, and that means the overall program is constantly changing. Now, most of it isn't changing, and so you want to, like, whenever you reconstruct your whole program view, which is what a type checker needs, you want to reuse as much of the old program view as you can. And that's why having immutable data structures, again, is super important, because you can just, in a 100-file project, when you're modifying just one file, if for every keystroke where you now have to reconstruct a new whole program view, you can take the 99 unmodified files and their ASTs and just slap them into the new program and then just worry about the file you're in, right? So from the get-go, our compiler was engineered in that manner. And you could almost say it was like a compiler that was actually very well suited for concurrency, but was sort of locked in a box
shackled,
that prevented access to the kind of concurrency that we need. And this was what I mentioned earlier, the shared memory concurrency. And the reason that's important is that if you think about how would you use concurrency in a compiler like ours? Well, parsing, for example, is an embarrassingly parallelizable problem. It consists of reading a source file into memory and then constructing a data structure that allows you to navigate that source file. Now, reading a source file into memory is just grab a string, put it in memory. Now build a data structure that allows you to, quickly navigate around in that string, and find particular places, the tokens in the string and the functions and the blocks and whatever, right? Mm-hmm. That work can happen completely independently for each source file. So if you have 5,000 source files and you have 8 CPUs, well, you can divvy it into 8s and then just have the CPUs go to work and then leave their data structures in memory. And then at the end of it, you can say, okay, now I have all the data structures. Now I can construct one thing that links them all together overall, right? But this only works if all of these processes are in a shared memory space. And that's where you run into problems with JavaScript, because JavaScript, the only way you get concurrency is web workers. And a key characteristic of web workers is that they are isolated from each other and they cannot share memory. The only thing they can share is like a way of communicating JSON back and forth, or maybe a byte array, but not anything, and no structured data can be shared. And so we could do all of this parsing in parallel in JavaScript, but then we'd be left with like these 8 little isolated worlds that each had an eighth of the world view in them. And in order to put it all back together, we would have to marshal across the boundary. And that takes longer than parsing the source files to begin with. So now you've given it all up again, right? So that's one way where concurrency helps us a lot, right? And of course, Moore's law, long time ago, stopped giving us faster CPUs. Instead, it's giving us more CPUs. And so if you can't take advantage of that, you're leaving a lot of money on the table. And so now we can take advantage of it. And luckily we had an architecture that allows us to do that very easily. So turning the parse and bind phases into concurrent binding and concurrent parsing was trivial. I mean, wow. I kid you not. We're talking about like 10 lines of code or whatever to run this stuff in a Go routine. Oof. And then a few places where we access a shared resource, for example, the thing that generates unique serial numbers or whatever, I mean, that needs to be protected by a mutex and whatever. And then you're done. And kaboom, it runs 3 to 4 times faster. That is literally the experience.
That's a powerful 10 lines of code.
Oh, yes. Now, it was a little more complicated with the type checker because unlike parsing, type checking is not something that is isolated per file, right? Like the whole idea of the type checker is to have a whole program view such that things can import from other files and you can cross-reference. And that means that whenever you say let X : some type name, well, that some type name may actually come from another file. And now you have to go over there and then start resolving stuff over there. And so you're crossing a lot of boundaries. And we thought hard about how can we be, because we also know that like that check phase is the thing that consumes the most time when you compile. It's like it dominates. It's like 60-70% of the time goes into checking. And we came up with a scheme where we don't actually attempt to make our type checker concurrency safe such that 8 CPUs are banging on the same mutable data structures at the same time. That would be pretty hopeless. Instead, what we do is we take your program and then say, like currently it's hardwired to 4, but we may change this. But we take your program And then we divvy it up into quarters, meaning we say, here's a quarter of the files, another quarter, another quarter, and another quarter. And then we create 4 type checkers. We give them each the whole program, but then we tell them to only check that quarter of the files that we assign to them. And then they go off and party, because the only thing they share is the underlying AST, which is immutable. And then they build their own state to represent the types. And most of the types they check are local to the source files they were assigned, but sometimes they reach across and then they duplicate some work by resolving a type over here, but by and large, it scales. And so we see by doing that, we can get another, like I said, 3x by concurrently checking your program at the cost of consuming maybe 20% more memory because of the duplicated types that we realize. But that's a great bargain. We're still consuming less memory than we did in the old compiler, and now we get to go 10 times faster because this is multiplicative, right? These are factors. So if you get 3x from native and you get 3x from concurrency, then you're pretty much at 10x.
It's a big paradigm shift for sure. Yeah. Well, I mean, I want to look forward down the road, thinking about what this really means for the next 10 years or a dozen years for the TypeScript project. Do you think that there's any change that could come about to language features? I have to tell you, actually, I've been advocating for fewer language features and more work on stability and these kind of things for a long time. So I'm very happy if nothing. If a lot of people have asked me with the Doom project, what could TypeScript have added to make this easier? And I'm like, what's there now runs Doom. I think we can call it.
Yeah, real. It's clearly Turing complete.
Yeah.
So yeah.
But I'm just curious if you have any. If there's been any moments, maybe if you don't want to tell me, that's okay. You're going to keep it close to the chest. But has there been any moments of things like that you didn't implement in the past because you knew that it would be a huge performance overhead, that now maybe this new chapter could, in a year from now, open some doors to things? Yeah.
I think actually the thing that I'm probably the most excited about. Well, first of all, I will say that if we had tried to do this, say, 2 or 3 years after the introduction of TypeScript, it's not clear that the world or even we would have been ready enough. But we've now reached a certain level of maturity, right? I mean, ECMAScript is certainly not evolving as fast as it did back in the old days with like the transition from ES5 to 6, right? Where, oh my God, we got classes, we got lambdas, we got blah, 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 we got all sorts of stuff, right? Now it's going a lot slower. And we also see from the feedback in the community that more and more what people are concerned with is scalability and performance, and less with like fanciful new features in the type system, right? Now, we will, of course, continue in perpetuity to track the work of the ECMAScript committee, and we participate there actively. And any new features that come along as a result of that, we will definitely give them treatment in the type system as is appropriate, right? We may dream up new type system features as well, but I think far more interesting is thinking about the implications of having a type checker that is 10 times faster when you couple that with all of the stuff that's happening in AI and agentic programming and whatever, and like, what could we do with information that we can produce 10 times faster, like contextual information for the LLM about like, what are these types actually resolved to? What is this symbol? Which symbol? Where was this actually declared as? Because all the LLMs look at right now is just the spelling of it. It doesn't really know. And so we could imbue it with a lot more higher fidelity information, in a real-time manner, right? We could also in a real-time manner check the output of AI to ensure that it is not just syntactically, but also semantically correct, which is something you're going to want if you're going to have these things generate code and you're going to actually hand them the keys and run it,
Yeah.
I mean, who's to say that this code is safe? I mean, the only way you keep the AI honest, so to speak, is to to put it through a deterministic type checker, right, or verifier. So I think there's some really interesting new avenues there that previously we were just not in a position to pursue that we can now start thinking about. So,
is one of those avenues in the future ever? I've wanted for many years like a TypeScript native runtime. There is Deno, of course, which is written in Rust. So maybe there's some crossover here with this work. But do you think that there's ever a future where we'll have a kind of TypeScript first runtime that's built on this code base?
Well, I've learned to never say never, right?
Okay.
if anything in this industry and in my journey through it, right? I mean sure, that could happen. I will say that some of the things that slow down JavaScript today in where the predominant runtime is V8, right? And JIT compiling and what have you is certainly one of the factors that you might be able to do away with in a more natively compiled system. But there's also JavaScript's object model. And like the ability to just at will impose new properties on an object, like these expandos that you can have, the ability to compute property names. Like objects are much closer to hash tables in JavaScript than they are to like structs that are laid out in memory slots. Even though we may think of them that way, they don't actually behave that way, right? I'd like JavaScript's treatment of numbers, like the fact that there are no ints at all. Everything is a floating point number.
Right.
There are just a bunch of things that those you're not going to be able to do away with if you want the same semantics. Now, you could dream up a language that looks like TypeScript, but has different semantics, and people have tried to do that. And then you could build a native compiler for that. But is that what people are looking for? It's hard to say. Right. So I don't know where this will all go. I have often wished for some sort of magic sprinkling pixie dust that we could do to get like a native runtime for JavaScript that would go an order of magnitude faster as we are now. But honestly, I just don't see that happening, at least not in the foreseeable future. But who knows?
Yeah, it makes sense what you're saying. I'm an enthusiast, so these are the things I sit around and dream about. You don't fault me for it.
Yeah.
The last question I really had was, I think that when I have seen tools move to Rust, I've seen I don't want to say backlash is maybe too strong of a word, but I've seen concern in the community that falls into the category of, well, you had all these contributors that were happily contributing TypeScript and JavaScript, and then the tool moved to Rust, and that like is going to just jettison all of those people, or it's kind of like forcing them to learn Rust. And maybe you could say the same complaint about, TypeScript, in Go. I'm wondering if you have any. I actually look at it as a net positive, to be honest. There's a lot of energy in these various communities, and I think we've seen the success of these Rust tools, and it's evidence that, and Zig tools for that matter with Bun, it's evidence that people are willing to try to, go outside of their comfort zone for something that they care about. But I'm just curious if it was a consideration for you at all about third-party contributions. There's been some great third-party contributions to TypeScript.
I mean, of course, the community of people who know Go and JavaScript both is smaller than the community of people who just know JavaScript, right? I mean, so fewer people, but then again, there's only so many people who contribute to the compiler, and they tend to be very interested and often have cross-pollination into native environments as well. I will say too that the transition from JavaScript to Go is actually pretty gentle on the system. It is not a super different, super complicated language with an awful lot of ceremony, which I would say Rust comes a lot closer to that, right? I mean,
you'd be right.
Rust is more of a modernized C++ than it is a modernized JavaScript, right? And Go is actually kind of, in some ways, a modernized native Python / JavaScript-y thing, But
when I used to write Go, I used to write Go professionally for like about 2 years. And during an all hands engineering meeting, there were some engineers complaining about how that one of them said it's mediocre, and they just weren't satisfied with not being able to do fancy things in Go. And the CTO, I'll never forget, stopped them and said, "You have to understand that Go is mediocre by design."
Yes.
It's
Yes.
not trying to be fancy.
No, it's trying to be a simple language, and honestly, it is, but the results are not mediocre. I mean, 10x, there's nothing mediocre about that, right? So,
Absolutely.
So you can do great things with this thing.
Kubernetes is not a mediocre software project by any stretch. That's awesome. Well, I have to say, I'm very, very excited for this next chapter. I think this is a great move, and I think it sounds like a really well-reasoned decision. And I'm glad you guys took so much effort thinking through all the different areas of this, from third-party contributions to just every element of it looks like it was examined. And I'm really glad that, of course, you take the project really seriously, but it's just nice to see anyway. I've always been a big fan of the work that this team has been able to produce all along. It's pretty incredible that something like this has made it as far as it has, with as much functionality as it has, and is still going strong. And we're about to see a brand new chapter. So congratulations to you and the team.
Thank you.
On all of that.
And I will tell you, we're all super excited about this, because this is definitely like a shot in the arm for the team, and I think it will be for the community, and I think it's gonna open up yet another fantastic decade for TypeScript of exciting things to happen. Which we're super enthused to be gearing up for that journey.
Thank you for joining us, and it's been really amazing to hear all this detail. I think it's going to be really valuable for library authors and people who are at the forefront of TypeScript.
My pleasure. Thanks for having me.
If you liked this video, then you might also like to know that Jake Bailey from the TypeScript team will be speaking at SquiggleConf about the team's journey porting TypeScript to Go. It's in Boston on September 18th and 19th. Thanks for watching.